30 degrees, 45 degrees, 60 degrees.
90 degrees.
Okay. Alright, and the pattern I told you for sine is square root of the top over 2. Cosine, square root of the bottom over 2. And tangent, square root of the top over square root of the bottom. Alright, so we're going to use that to fill out this table. Now, there's a table on the handout I gave you yesterday. There's also one on this because we're going to fill this out a lot. This will be a quiz that we probably take a couple times in this chapter, so easy points if you learn it. It'll also be the first page of your test when we take this test, so that's why I gave you several copies of it so you can practice it. Okay, the sooner you learn this, the easier this class will be because we need these values. But I'm not just asking you to memorize a ton of stuff. I'm giving you tricks to do it. So let's talk about the sine. Okay, if I'm looking at 0 degrees, so what would I do? Fold in my 0, fold in my thumb. Okay, I told you sine is square root of the top over 2. So how many fingers do I have above the one I folded in?
0.
So square root of 0 over 2, which is just 0. Alright, let's go ahead and do cosine of 0 degrees. So cosine I said was the square root of the bottom over 2. How many fingers do I have below that?
4.
Square root of 4 is
2.
divided by 2.
1.
Alright, how did we get tangent? Square root of the top over square root of the bottom. So square root of 0 divided by the square root of 4, which is 0. Alright, we'll come back to secant, cosecant, and cotangent. Let's go to third. So the sine of 30 degrees would be?
Square root of 1 over 2.
Which is just 1/2. Cosine of 30 degrees would be?
3 over 2.
And that doesn't reduce. Tangent would be square root of 1 over square root of 3. But we can't leave that radical on the bottom, so multiply top and bottom by radical 3. And we get radical 3 over 3. 45 degrees. Does everyone see how I'm getting these values? So the sine of 45 degrees
Square root of 2 over 2.
cosine of 45 degrees, tangent of 45, which is 1. Okay. 60. So sine of 60 would be sine or cosine of 60. And tangent, square root of 3 divided by the square root of 1, which is just the square root of 3. Alright, 90 degrees. So the sine of 90 would be? So 2 over 2 is 1. Cosine of 90? 0. Tangent, we have the square root of 4 divided by the square root of 0. What's that? Okay. If I have this, I can get the rest. Okay, if I have sine, what do you do to get cosecant? Flip it. So what is the reciprocal of 0? This reciprocal of 1/2. If I flip this, I get 2 over the square root of 2. Get the radical off the bottom, so that's 2 radical 2 over 2, which is the square root of 2. 60, if I flip that, we get 2 over the square root of 3. So that's 2 radical 3 over 3. And 90, reciprocal of 1 is 1. Alright, how do we get secant? flip cosine. So reciprocal of 1 is reciprocal of radical 3 over 2. Can I just write the 2 radical 3 over 3? I already worked it out one time to show you where it came from. Reciprocal of radical 2 over 2. Reciprocal of 1/2. And reciprocal of 0. Alright, how do I get cotangent? Reciprocal of tangent. Reciprocal of 0. Okay, if I take radical 3 over 3 and flip it, yeah, get 3 radical 3 over 3, or just the square root of 3. Reciprocal of 1. Okay, reciprocal of radical 3 is 1 over the square root of 3. Radical 3 over 3. What is the reciprocal of undefined? 0. Does everyone know where I got all these values? Okay. So here's some quick things to check yourself. Remember yesterday we talked about cofunctions, right? And I said that cofunctions are equal when their angles are complementary. So that means the sine of 0 should be the same as the cosine of 90. Sine of 30 equals cosine of 60. Sine of 45, cosine of 45. Sine of 60, cosine 30. Sine of 90, cosine of 1. So the cofunctions will have all the same values, just reversed. So tangent and cotangent. So 0 and 90. Just the same values, but reversed. And secant and cosecant. So if you're doing this on a test or something and you want to quickly check yourself, look at that. Once you have sine, cosine should be the exact same thing backwards. Same for secant and cosecant, tangent and cotangent. Any questions for me at all? If the hand trick does not make sense to you, please tell me. I can give you other tricks to help. I just don't want to throw like 6 different ways out there and confuse everybody. So if that works, we'll go with that. But if the hand trick does not make sense to you, tell me and I will give you other options for how to learn those. All right, let's go to the handout we had yesterday. I think we have a couple examples left on it. So we just did a table. So I want to simplify 2 cosine of 30 degrees. So that means we are going to do 2, oh my goodness, maybe not, 2 times, all right, cosine of 30. So I could look at my table or I'm just going to practice using my trick. So I fold in my 30, cosine's the bottom, so square root of 3 over 2, and we get square root of 3. I want to caution you about using your calculator on these things. If you put the radical in your calculator or try using the cosine button on your calculator, it will give you a decimal, and I'm not going to accept that. I want the radical form. Okay. B, tangent of 45 plus tangent of 60 squared. So tangent of 45 is what? 1. Plus, what's the tangent of 60? Radical 3 over radical 1, which is the square root of 3. And I want that squared. How would I square that? Well, means you have 2 of them. So you get 1 plus radical 3 plus radical 3 plus 3. Final answer 4 plus 2 radical 3. C. Sine squared 45 degrees means take the sine of 45 degrees and square that answer. So what is the sine of 45? minus 2 times the sine of 45, square root of 2 over 2. Cosine of 45 is also square root of 2 over 2, plus the cosine of 45 squared, so radical 2 over 2 squared. After we squared, yeah. All right, so if we square these, radical 2 times radical 2 is just 2. 2 times 2 is 4. So 2 fourths or 1/2. And multiply this, I could drop 1, 2. Radical 2 times radical 2 is 2 over 2, which is just 1. And radical 2 over 2 squared again is 2 over 4, which is 1/2. And we get 0. Any questions on those? So the last thing I have, these problems are a little bit longer, so if you write big, you might need another sheet of paper. I'm asking you to find the exact value. So exact value means radicals, no decimals, for each variable. And if you look, I have actually 4 different variables. So each of these pictures, we're finding 4 different things. One thing, if we're going to use a trig function, what kind of triangle do we have to have? A right triangle. So if I look, is this whole triangle a right triangle? No, but I have 2 right triangles here. I have this one on the right, and we have one on the left. Okay, I am going to start with my pink triangle because I did give you one side measurement in that. We have to use our angle to help us here. So this is 30 degrees. If I want to find side B, B is across from that. Is that opposite, adjacent, or hypotenuse? Opposite. And 12 is the hypotenuse. Which trig function involves opposite and hypotenuse? So what we can say is the sine of 30 degrees equals my opposite side, which is B, divided by the hypotenuse, which was 12. What is the sine of 30 degrees? 1/2. So I can substitute that in. Cross multiply. And we get that side B is 6. There's a couple different ways we could get side D. Can you think of one?
A squared plus B squared equals C squared.
Yep. If you have a right triangle, once you know 2 sides, you can do Pythagorean theorem to get the third. What's the second way we could do it? We could do another trig function. We could do opposite and adjacent. We could do adjacent and hypotenuse. We have a couple different options because we know 2 of the 3 sides now. So which way do you guys want me to do it?
A squared.
Okay. So so side D squared plus 6 squared equals 12 squared. Okay, so we know I want exact values. So we need a perfect square that goes into this. 36 and what?
3.
So that would be 6 radical 3. All right, 2 variables down, 2 to go. There is one thing we could use to quickly find side A. can you guys just look at this and tell me what side A would have to be? What is it? Not quite. If this is 45, this is also 45, right?
Yeah.
If these angles are the same, what does that tell you about sides A and D? They're the same because it's an isosceles triangle. So if side D was 6 radical 3, that means side A is also 6 radical 3. Now we could have gotten it by doing a trig function or something as well, but this is a nice time saver if you recognize that. Okay, we need side C still. So let's do a trig function. You could do Pythagorean theorem now, but I'll do a trig function. If I'm viewing from my 45-degree angle, side D is the opposite, C is the hypotenuse. So what trig function? Sine. So the sine of 45 degrees equals my opposite side D, which had a measure of 6 radical 3, divided by my hypotenuse. What is the sine of 45 degrees?
Square root 2.
So if we cross multiply, we get radical 2c equals 12 radical 3. Can you leave a radical on the bottom? So you have to multiply by the square root of 2 on top and bottom. So we get 12 radical 6 over 2, which reduces to 6 radical 6. So we really are forced to use a trig function on the first one, but after that we kind of had a lot of options for how to go about it. Let's try another. I do have a typo in this picture. I meant to say that this is a right angle right here. So we might draw that in. So again, we know the trig functions only work if we have a right triangle. And we have 2 of them. One right here. And one right here. Could I start on my green triangle in this problem? Why not? Right, we don't have any of the sides. So you have to start in the triangle where you have at least one side. All right, so let's say I want to, well, are there any sides I would know automatically? P. What's P going to equal? 15, because again, I told you this was a 45, 45, 90, so these have to be the same. So what might be the easiest way to find R? Yeah. What would I break that into?
We do 225
Mm-hmm. So you get 15 radical 2. All right, so we're halfway done. If I wanted to find Q next, so if I did from my 30, Q is the opposite. I now know R, which is the adjacent. What trig function uses opposite and adjacent? Tangent. So the tangent of 30 degrees equals my opposite side Q over my adjacent side, which was 15 radical 2. What is the tangent of 30 degrees? Square square root of 1 over square root of 3, which turns into radical 3 over 3. You move your radical. Cross multiply. Divide by 3, so q is 5 radical 6. And one last variable. How do you want to find t? Give me one option. Okay, we could do Pythagorean theorem. Let's try that. So it would be r squared plus q squared equals t squared. R is 15 radical 2 squared. Q is 5 radical 6 squared equals t squared. All right, I want to make sure you guys know how to square when you have something like 15 radical 2. You have to square the 15. So 15 times 15 is, you have to square the square root of 2, and then you multiply those together. So that's 450. Okay, 5 radical 6 squared. So 5 squared is 25. Square root of 6 squared is 6. So 25 times 6. We get t squared equals 600. What would you break that into? So t is 10 radical 6. Lots of options for how to solve these problems. You guys have questions for me there? So I think I gave you this assignment yesterday, but you have the rest of the hour now to work on this question.